Good evening, everyone. My name is Lushain.
Hi, my name is Wanur Ahlami.
Hi, my name is Siti Nabila.
Hi, my name is Siti Nabila.
Hi, my name is Mohammed Aziz.
Today, we are going to discuss Chapter 3, Numerical Method. Numerical method is a mathematical tool designed to solve numerical problems. The implementation of a numerical method with an appropriate convergence check in a programming language is called a numerical algorithm. Can you tell me some daily application of numerical method, Alami?
Yes, Jaying. One of the examples is we use numerical method in civil engineering. In many aspects of our life, a huge amount of different materials are used. Glass, wood, metals, concrete, which are directly used almost every minute in our everyday life. Thus, the modification of materials and prediction of their properties are very important objective for the manufacturers. In order to produce high quality materials, the engineering industry, among other problems, are very much interested in the elastic behavior or loading capacity of the material. So, to manufacture a new product with high quality, a detailed investigation of the material on the atomic level is not required in most cases. Mathematical model is needed for the quantitative description of the change of material properties under external influences. The concept of differential equation come to help us as an excellent tool for the development of such a model. Do you agree with that? Numerical bring a lot of that benefit to our life, Bella?
Yes, I agree with you, Alani. In addition, airline companies also use numerical methods as a way they make estimation price for some of their activities. It might not seem obvious, but airline companies use numerical methods to optimize their ticket price, keep a check on their fuel needs, payroll, and many other activities. Sophisticated numerical methods technologies have made it possible to generate accurate approximation of quantities that can't be computed otherwise. Thus, the field of study stemming from numerical methods lead researchers to look for more problems for them to solve that were closely related to our day's issues. I also heard that numerical methods are also used in technology field. Is it, Nabila?
Yes, you are correct. Sophisticated numerical analysis software has become indispensable in modern life. People are able to perform mathematical modeling even if they are unaware of the simulations involved. This can only be achieved through reliable, high-end, and efficient software. Some of the major applications of numerical analysis is car safety enhancements. Usually, car makers around the globe use numerical simulations to evaluate and enhance car safety. Pedestrian protection is also kept in mind while investigating car crash tests. The algorithm involved are partial differential equations and fed to the advanced computer to unravel optimal results. Can you tell me some applications of numerical method in mechanical engineering, Hazim?
Okay, so in mechanical engineering, when we build the tracks for train, LRT, and monorail, we know that there is a gap between the track. So, and you know what is the reason that we build the gap between the track? So the reason is to allow the track to shrink and expand during cold and hot days. The thing is, without a proper gap distance, there is a potential that the track can be damaged by overexpanding, which can cause the track to collide and overlap, or it can shrink and cause a big size gap that is very dangerous to the passengers on the train, as the train can detach from the track. So the proper size of the gap can be determined using the help of interpolation, when the maximum, minimum, and average cases are calculated to get the precise gap size.
Numerical methods are also used in simulations in different fields. Usually, simulation refers to the actual running of the program that contains algorithm and equations. In engineering, it is most often the simulation of the evolution of a physical system over time by solving one or a group of mathematical equations that model the physical system. Shayi, could you share with us about how numerical methods are used in weather prediction?
Sure. Numerical weather prediction (NWP) is a method of weather forecasting that employs a set of equations that describe the flow of winds. These equations are translated into the computer code and use governing equations, numerical methods, parameterizations of other physical properties, and combined with initial and boundary conditions before being run over a geographic area. Almost every step in NWP includes omissions, estimations, approximations, and compromises. Numerical methods is created for weather prediction because computers can perform arithmetic but not calculus. Numerical method is used to convert spatial and temporal derivatives into equations that computers can solve. Numerical methods also directly affect model output, mostly at small scales. Bella, do you know that numerical method also used in transient analysis?
Yes, transient analysis can be described as the analysis of a system in an unsteady state. Transient analysis is very important since it can be used in analyzing the performance of any electrical circuit. Thus, for an electrical current or voltage flowing through an electrical circuit, there can be various forms of the voltage or current. For instance, considering circuits which are time-varying signals with resistive circuits, which the resulting in Kirchhoff current law and Kirchhoff voltage law are normally in the form of differential equations rather than algebraic equations. But these differential equations are not easily solved analytically when the order is high and complex. Therefore, numerical methods are one of the best techniques in solving almost all mathematical equations that cannot be solved analytically. A number of these methods have been designed to solve such equations, especially in differential equation. What do you think, Nabila?
Numerical methods also can be used in financial industry. For instance, modern businessmen make use of numerical techniques to allocate their resources efficiently. Some of the problems addressed by such applications are manufacturing, storage, investment, and others. Quantitative analysts have expertise in this area and use the algorithm in risk management and interest calculation. What do you think, Hazin?
I agree with what you just said just now. Um, so, business like as in business like a company with an air or water transportation company such as Asia or MAS. Unlike land transport, air and water transportation don't have a visible track or road that they can follow. So by calculating each factor, they can minimize the risk and avoid major loss um, because by calculating the factor using numerical method, it can really help in preventing the ships or the airplanes from crossing path and avoiding collision, which can cost a lot of money and it is not good for the investment lah. Um, so the set of all points in air travel and water travel need to be correct so that the track they were using will have the shortest possible time and distance travel without affecting the other ship or aircraft path. This is because when using the shortest possible time and distance, it can minimize the usage of fuel. So it can we call cut cost lah. Uh, so this is possible due to the Newton-Raphson method.
Numerical method also used in traffic signals. Mathematical modeling of traffic flow began to develop from the middle 20th century and today is becoming increasingly important due to the rapid development of big cities and their infrastructure and a growing number of vehicles per capita. In the development of the theory of traffic flows was formed two main approach to these problems, which is the macroscopic, which consider the traffic environment as something more usual as quickly compressible liquid, and microscopic, which considers every vehicle as a single particle with its speed and the final destination. Numerical method is mainly used for microscopic stimulation.
The reason why we use numerical method is because it gives approximate solutions and they are much easier when compared to analytical methods. When analytical solution is impossible, this means that we have to apply numerical methods in order to find the solution. The analytical solution is to know absolutely how the model will behave under any circumstances, but it works only for simple models. Many systems possess complex functionality that it is hard to track the system. We turn to numerical methods for solving the equations, and a computer must be used to perform the thousands of repetitive calculations to give the solution.
Great information, Alani. So here I want to share analytic about application for numerical methods, which numerical methods also used in spacecraft dynamics. A spacecraft is a vehicle or machine designed to fly in outer space. A type of artificial satellite, which is spacecraft, are used for a variety of purposes, including communication, Earth observation, meteorology, navigation, and other. Space travel use numerical methods to make approximation on the spacecraft trajectories. Space has no gravity in it, and therefore the dynamics of motion operate very differently than on Earth. So numerical analysis come handy in making this estimation with the help of linear as well as nonlinear equations that are computed by onboard computers. Solving simple differential equations is the key in this application of numerical analysis. What do you think, Nabila?
In numerical analysis, Newton's method, also known as the Newton-Raphson method, is a root-finding algorithm which produces successively better approximations to the roots or zeros of a real value function. Newton-Raphson method is extensively used for analysis of flow in water distribution networks. Several efficient computer programs using Newton-Raphson method are also available for analysis of flow in large-size networks. It is the simplest and fastest approach to approximate the roots of any nonlinear equations.
I'd like to add some more information about spacecraft dynamics. Just like Nabila said just now. So recently, NASA has introduced a low thrust rocket design where the rocket can move on higher speed due to the lower fuel tank and it can save more fuel due to the low fuel consumption. This low thrust rocket design needs to be launched at the exact trajectory in order for it to work. It relies heavily on the optimization trajectory where it needs the help of numerical analysis and methods to help it reach the optimized trajectory. Without a proper trajectory, it will be very difficult for the low thrust rocket to be launched because it do not have enough thrust. So NASA said that this invention of rocket will be the revolution of a new fuel-saving spacecraft, which is very good for the environment as natural fuel is very hard to get. nowadays.
That's all for our discussion for today. Thank you all.